Hello viewers, welcome to IT Maths. In today's video, we'll be looking at factors and prime factors. But first, let's look at a factor. What is a factor? A factor can only be associated with another number. A factor cannot be a factor for nothing. So, a factor is simply that number that can divide another number without a remainder. What do I mean? I simply mean that for a number 2 to be a factor of another number, say 4, it should be able to divide 4 without a remainder. If 2 divides a number, say 5, and there is a remainder of 1, then 2 is not a factor of 5. Another example, if 2 cannot divide 7 and there is no remainder, then 2 is not a factor of 7. But if 2 can divide a number like 12 and there is no remainder, then 2 is a factor of 12. So, a number is only a factor of another number if it can divide that number without a remainder. If it cannot divide it without leaving a remainder, then it is not a factor of that number. Note, that number can be a factor of another number, but not necessarily a factor of this number. I hope that is clear. So, you can be asked, is 2 a factor of 4? The answer is yes, because 2 divided 4 and there was no remainder. You could also be asked, is 2 a factor of 12? The answer is yes, because 2 divided 12 and gave a whole number and left no remainder. But if you are asked, is 2 a factor of 5? The answer is a definite no, because 2 divided 5 and left a remainder of 1. The same thing with 7. 2 is not a factor of 7 because it left a remainder. So anytime a number divides another number and leaves a remainder, it means it is not a factor of that number. Now let's see another way a question can be asked in this topic. Write all the factors of 18. Now, this question is simply asking you to find out all the numbers that can divide 18 without leaving a remainder. The simplest way to answer this question is to start with the smallest number ever, 1, and then start building your multiplication table. Why do I need to build my multiplication table? Because multiplication is the opposite of division. If I know my multiplication very well, then I can know my division. So, let's start. 1 times what gives 18? Of course, 1 times 18 will give you 18. Now, how does that relate to my factor? If 1 times 18 is 18, it therefore means that 18, this product, divided by one of the factors of 18, is going to give me the other factor. Also, 18 divided by 1 is what? The other number, 18. So that's how multiplication relates to division. Okay, I've picked 1. Now it's time to pick the next bigger number, which is 2. 2 times what gives 18? 2 times 9 gives 18. How does that help me in getting my factor, a number that will divide 18? If you look very closely, you will see that this answer divided by 9 gives the other one. And also this answer divided by this other one gives this one. 18 divided by 2 gives 9. Now what am I building? I am getting all the factors of 18. all the numbers that multiply to give 18 are automatically factors of 18. Now let's proceed. The next bigger number is 3. Is 3 a factor? Let's see. If it multiplies a number and gives 18, then it is definitely a factor. Good. 3 times 6 is 18. It therefore means that 18 divided by 6 is 3. 3 can divide 18 without a remainder. It also means that 18 divided by 3 is 6. It means 3 can divide 18 and gives a whole number without a remainder. So all these numbers are factors of 18. The next number is 4. 4 times what gives 18? You find out that if you run your 4 times table, 4, 1, 4, 4, 2, 8, 4, 3, 12, 4, 4, 16, 4, 5, 20. You did not hear 18 there. It therefore means 18 cannot divide 18 by 4 and there won't be a remainder because it is not found in the 4 times table. So I skip 4, I go to 5. 5 times nothing gives 18. Let's try it. 5, 1, 5, 5, 2, 10, 5, 3, 15, 5, 4, 20. I skipped 18 again, which means that 5 is not also a factor of 18 because 5 times nothing gives 18. So the next number is 6, but look at this, we already have 3 times 6. So choosing 6 times 3 will be a simple repetition. So we've gotten to the end of our factors. So 1, 2, 3, 6, 9, 18 are all factors of 18. Let's try something else. Let's take this as number 1. Let's try number 2. Write all the factors of 24. How do we do that? The same procedure. Again, 1 times what will give 24? 1 times 24 will give 24. After 1, we said we check the next number. You don't just take it, but you check first. Does 2 times anything give 24? Yes. 2 times 12 gives 24. So that means 2 is a factor, 12 is also a factor. Let's check 3. Does 3 times anything give 24? Yes. 3 times 8 give 24. Let's check the next number, 4. 4 times 6 also give 24. 5 times nothing gives 24. 6 times 4 gives 24. But 6 is already here. And you know 4 times 6 is the same as 6 times 4. Multiplication is commutative. It doesn't change the answer. So we have all our factors. 1, 2, 3, 6, 8, 12, and 24. These are all factors of 24. So as you can see, to get a factor of a number is very simple. But one thing is certain. If you are not very familiar with your multiplication table, getting these factors is going to give you some problems. So I always advise my students to know their multiplication table. Spend time studying it. Spend time knowing it. It will help you solve multiplication and division problems. So you can see that finding the factor of a number is very easy. Just go through your multiplication table. So, if you are asked, is 3 a factor of 16? It's a very simple question. Run your 3 times table and find out if any of the numbers will multiply 3 to give 16. If any whole number multiplies 3 to give 16, then 3 is a factor. So 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12, 3, 5, 15, 3, 6, 18. We skipped 16. We did not hear any number. If we heard any number, that would have meant that 3 is a factor of 16. Meaning 3 times nothing gave 16. if 3 times anything had given 16, it would have meant that 16 divided by 3 is that number, which means 3 is a factor of 16. Is that understood? Now, try this for me. Write all the factors of 36. Please drop your answer in the comment section. So the next thing we'll be looking at today is prime factors. What are prime factors? Prime factors are simply factors that are prime. So, what do you mean by prime? What is prime? What number is a prime number? When is a number said to be a prime number? Prime numbers are numbers that have only 2 factors. Full colon itself and 1. So when you are searching for the factors of a number and it could only have 2 factors, and one of the factors is itself, for instance, I'm asking you to find the factors of 24, and then the only factor it has is itself, 24, and then 1. 2 couldn't divide it, 3 couldn't divide it, 8, 6 and the rest of them couldn't divide it like we truly have in the factors of 24, then that would have made 24 a prime number. But once the number does not have any other factor, the only factors it has are itself and 1. 1 divides every number. 1 can divide any number, because division by 1 simply means you are giving that number to one person. You're not sharing that number among 2 people, like 4 divided by 2. You're not sharing 10 divided by 2. You are ten divided by 1, which is still 10. So if you see a number written as 10, it means there is a division under 1. It's divided by 1. There is a divisor 1 under, though it is not written, because we expect that you know. If it were to be 10 divided by 2, the answer would have changed to 5. But it is not divided by 2. So you are giving that number to only one person. You are not sharing it among 2 people. You are not sharing it among many people. So it is only 1. So 1 is always dividing every number. If I write 5, it is actually 5 divided by 1. If I write 3, there is actually 1 under. Okay? So 1 divides every number. So a prime number will have 1. That is certain. Every number has 1 as a divisor. But it also has another number itself. There is no other number apart from 5 and 1 that can divide 5. There is no other number apart from 3 and 1 that can divide 3. And so on and so forth. So such numbers that when you check the factors that they have, it's only themselves and 1, which is a universal divisor. There is no other number that can divide it. That's the number we call prime numbers. Okay, let's take some few examples. Let's start with 1. The factors of 1 are 1 times 1 is 1. Is there any other number that can multiply to give 1? No. So the factors of 1 are what? Only 1. Only 1. 1 and 1. Remember when we did this and then this number is already here, it doesn't change anything, and this is 1 and this is 1, so we have only 1 factor. So that is what disqualifies 1 from being a prime number. 1 isn't a prime number because it has only 1 factor. Remember, a prime number are numbers that have 2 factors. 1 has only 1. Okay, let's go to 2. Factors of 2. 2 times 1 is 2. I should have said 1 times 2. Always start with the smallest number. It's the same thing. 1 times 2 and 2 times 2 are the same thing. So 1 times 2, 2. There is no other number. Now, what are the factors of 2? 1, 2. Does that qualify to be a prime number? Yes. 2 is a prime number. Let's go to 3. Factors of 3. 1 times what gives 3? 1 times 3. What again? 3 times 1. It's still the same thing. It's here already. So how many factors of 3 do you have? 1, 3. And then there is nothing else. So does that qualify 3 to be a prime number? Yes. 3 is a prime number. Now let's look at 4. 1 times 4 is 4. 2 times what gives 4? 2 times 2. The next number is 3. 3 times nothing gives 4. In fact, once you find two numbers like this, it means nothing else higher than that can actually give 4. So is 4 a prime number? It has 1, 2, 3, 4 factors. It's definitely not a prime number. Let's go to 5. 1 times 5 is 5. 2 times nothing gives 5. 3 times nothing gives 5. 4 times nothing gives 5. The next number is 5. So 5 times 1 is 5. It's already here. So how many factors? 1 and 5. 2 factors. So 5 is a prime number. Let's go to 6. 1 times 6. 2 times 3. 3 times 2. How many factors is that? 1, 2, 3, 4. 6 isn't a prime number. What about 7? 1 times 7 is 7. 2 times nothing gives 7. 3 times nothing gives 7. 4 times nothing gives 7. 5 times nothing gives 7. 6 times nothing gives 7. The next number is 7 times 1, which is already here, gives 7. So 7 is a prime number. The next one, you might think, okay, you say, okay, 8 is even. As a matter of fact, all even numbers are not going to be prime numbers, except for 2. What qualified 2 to be a prime number is because it has only 2 factors. If not for that, I don't think 2 would have been a prime number. But the definition says a prime number must have only 2 factors, itself and 1. And that is what qualifies 2 as a prime number. So apart from 2, every other even numbers are not going to be a prime number. Every other even number is not going to be a prime number. But that doesn't mean that all odd numbers are prime number either. Okay, so I said that to say that I don't need to try 8. 8 is not going to be a prime number. You can try it and then you find out. Okay, I'll try 9. Because 9 is not an even number. But like I said, not all odd numbers are prime. So let's find out for 9. 1 times what gives 9? 1 times 9. 2 times nothing gives 9. But 3 times 3 gives 9. And that has given us 1, 2, 3, 4 good factors. And that disqualifies 9 from being a prime number. So like I said, you wouldn't just know a prime number because it is an odd number. It doesn't work like that. You have to be very familiar with your multiplication table. By knowing your multiplication table, the inverse gives you your division, and then you get your answer and know which number is prime and which number isn't prime. So viewers, that is it for prime numbers. But I would like you to try something for me. Write down all prime numbers from 0 to 30 and drop them on the comment section for me. Meanwhile, don't forget we're dealing with prime factors. We had to clear that out of the way, what a prime number is, so that we can now understand what prime factors are. So, what is a prime factor? A prime factor is a factor that is prime. What does that mean? It means it has 2 things. It is number 1, a factor of another number, and number 2, it is not just any of the factors we learned, it must be a prime number. So a simple question could be, find the prime factors of 3. And then you would do 1 times 3 gives 3, giving you 1 and 3 as factors of 3, and that is absolutely correct. But in this case, we are only looking for prime factors. So the only prime factor of 3 is 3, not 1, because 1 is not a prime number. That's simple. Okay, if I ask you to find the prime factors of, let's say, 12, what would you do? You start by saying 1 times 12, 2 times 6, 3 times 4. The next is 4 times 3, but 3 times 4 is already here, and it's the same thing. So prime factors of 12 would be, I wouldn't write 1 because 1 is not a prime number. I would write 2, I would write 3, I wouldn't write 4 because 4 is not a prime number. I wouldn't write 6 because 6 is not a prime number, and I wouldn't write 12 because 12 is not a prime number. Do you get? So the only prime numbers, prime factors of 12 are 2 and 3. Is that okay? What about the prime factors of 30? Again, 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. If you go on, you have something like 4 times nothing, giving you 30. But 5 times 6 gives you 30. Again, the next is 6 times 5, but it's already here. So that means that's the end of our factors. But which of them is prime? We only have 2, 3, and 5. So the factors of 30 that are prime are 2, 3, and 5. That's one way to find the prime factors of any number. But the problem with this method is that it makes you go around searching for all the factors, even the ones that are not prime, before you now sit down to select the ones that are prime. So in this next question, we are going to employ two methods. One, the one we just finished using, and then another method that we won't have to go through finding all the factors, even the ones that are not even prime. The question says, express the following numbers as a product of its prime factors. So it means express the first one, 12, as a product of its prime factors, express 30 as a product of its prime factors, and then finally we express 42 as a product of its prime factors. We all know what product is. Product is a number we get when we multiply two or more numbers. So if we are expressing 12 as a product of its prime factors, it means I want to see prime factors here multiplying to give this product 12. So I'm not going to just pick any number that will multiply to give 12. All the numbers that are going to multiply, remember they are all factors of 12. These numbers are going to multiply to give 12. They must not be just any factors, but just prime factors. That's just what we are trying to do here. So I'm going to start by solving this question wrongly. Okay, wrongly in a way, yes, because I'm not going to use prime numbers. I'm going to use our first method that said, okay, so let's express 12. Okay, so what would we do? You say 1. I don't want to use 1 times 12 because I won't be changing 12. I'll still be stuck with 12. So let me start with 2 times what gives 12? 2 times 6 gives 12. Now this is correct. This is factors of 12. Very correct. Product of 12, and they both multiply to give 12. So yes, it's correct. But the problem is that one of them isn't prime. 2 is a prime number, 6 is not a prime number. We were asked to express as product of its prime factors, not just any factor. So how can I eliminate 6 and then still have my answer multiply to give 12? If you know your times table very well, you know that you have 2 times 3 gives 6. So that means inside 6, I have 2 times 3. So why not remove 6 and write 2 times 3 in place of 6, since it still means 6. So that would mean I could do 2 times 2 times 3, 2 times 3. So let's check. 2 times 2, 4, 4 times 3, 12. Now I have succeeded in expressing 12 as a product of its prime factors. Look at 2 is a prime number, it's still the same 2, which is a prime number, and 3 is also a prime number. No other factor is here that is not prime. So we've succeeded in expressing 12 as product of its prime factors. Let's look at 30. Again, I'm going to start with 2. Never 1, because 1 won't change the number. I'll still have 1 times 30. So 1 times what gives 30? 1 times 15. We saw that already earlier on. But the problem is, how can I break this other guy that is not a prime number? 15 is not a prime number because it has more than 2 factors. Remember, our definition for a prime number is that it must have only 2 factors, and 15 here has more than 2 factors. So we have to break down 15. How do I break down 15? What is inside 15? 1 times 15 won't work. I'll still have 15, and 1 isn't prime at all. 2 times nothing gives 15, so it won't work. What will work? 3 times something. 3 is a prime number. Good. 3 times what gives 15? 3 times 5. So you see, we've succeeded in eliminating 15 and replacing it with 3 times 5. So I'll write this again. 2 times, instead of writing 15, I'll write 3 times 5. And then if you check it out, 2 times 3 is 6. 6 times 5 is 30. So we've succeeded in writing 30 as a product of its prime. This is wrong. This is wrong. Remember, I told you I'm going to solve it wrongly as a child that does not really know what to do yet, but has an idea. Okay? Now, 2 times what gives 42? 2 times 21. But the problem is, 21 isn't a prime number. So, how do I break 21 down into prime factors? 3 times 7 gives 21. So I'm going to write here 2, that is this first 2, times this 3 times 7. And I'm going to check, is this a prime number? Yes, it is. Is this a prime number? Of course it is. If either of them weren't a prime number, I would have still looked for a way to break it down to make it a prime number, so that all my factors can all be prime. I hope you understand. So the answer to this first number is 2 times 2 times 3. 30 is 2 times 3 times 5. 42 is 2 times 3 times 7. Now, having said that, I want to proceed to another method that will not even make me go through here. Okay? And then that method looks like the method we use in solving LCM. But it is not exactly LCM we are looking for, but it just adopts that method. So I'm going to start with the first one, 12. And then I'll be picking factors that can divide 12 until I can't divide it anymore. But the thing is that this column here, I will not simply pick any number. I will only pick prime numbers. And the smallest prime number is what? 2. When I'm done with 2, I'm still going to pick 2 until I can't pick 2 again, and until 2 can divide the number again. And then I move to the next prime number. I am never going to use any other number here that is not a prime number. That's the rule for this second method. So let's start. 2 goes into 12. 2 times what gives 12? Then that is the answer to 12 divided by 2. 2 times what gives 12? 2 times 6. So 12 divided by 2 is 6. That's how to get your answer. Okay, so 2 goes into 12, or 12 divided by 2 is 6. 2 can still go, so I'm going to pick 2 again. 2 goes into 6 is 3. What can now divide 3? Only 3 can, because it is a prime number. So our answer becomes, we are going to bring all these factors we use in dividing, and then that becomes our answer. And we place a multiplication sign between them. Let's find out. 2 times 2, 4 times 3, 12. So we've succeeded in expressing 12 as a product of its prime factors. I told you this method will not go through giving us a number that is not a prime number yet. Let's use the same method for 30 and then for 42. So we begin. Again, we start with the smallest prime number, 2. 2 goes into 3. 1, a remainder of 1. I place that remainder 1 here, and this makes this number 10. 2 into 10 is 5. Now, I go to use 2 again. 2 cannot divide 15 without a remainder. So 2 is not a factor of 15. Remember what we learned factors? 2 isn't a factor of 15. So I go to the next prime number, which is what? 3. Can 3 divide 15? Before I write it down, let's check. Yes, 3 times 5 is 15. Therefore means 15 divided by 3 is going to give 5, a whole number. So I can take 3, and that is 5. Can 3 go again? No. This is a prime number. No other number can go into it except itself and 1. And 1 will not make any difference. So we never use 1 to divide. Okay, so we have 5. So our answer is 30 is equal to 2 times 3 times 5, as we had earlier on. And 2 times 3 is 6. 6 times 5 is 30. So we've succeeded in expressing 30 as a product of its prime factors. And lastly, we had 42. The same thing. 2. 2 goes into 4. 2. 2 goes into 2. 1. Can 2 go again? No. 2 does not divide odd numbers. This is an odd number. So what can divide 21? That's why I always encourage people to know their multiplication table. With this, you can easily see 21 in the 3 times table, and it is 3 times 7 that gives 21. So you have 3. 3 goes into 21, 7. What can go again? Can 3 still go? No, 3 can go because this is a prime number. So we have 7. So our 42 expressed as product of its prime is 2 times 3 times 7. And that is our answer. So here is a quick one before we go. What number would divide 17,335? 2 will not go because this is an odd number. Can 3 go? Let's find out. 3 goes here, 2 remain, 2 will remain again, and 1 will remain, and 3 can go into 15. So 3 can actually go. So we take 3. 3 goes into 17. 15 can go. That is 5. A remainder of 2. I used 15. I didn't use the entire 17. I only used 15 because 15, 3 times 5 is 15. So I used 15. A remainder of 2. Here, this is 23. 3 into 23. I can see 3 times 7 giving 21. So it means I have 7. I was able to use only 21. It means 2 is remaining from 23. So we have 2 remaining. Again, 21. I've used 21. 1 is remaining. 3 goes into 22. I used 21 and shared. I had 7. 1 is remaining. I put the 1 here. 3 into 15 is 5. I'm just doing this for the benefit of those who are still finding it difficult to divide numbers. Now can 3 still go? Let's check. 2 remain. 1 remain, and this 15. It can go. So we check. 3 into 5 is 1. I only use 3. So 2 remains. I put 2 here. 3 into 27 is 9. Because 3 times 9 is 27. Nothing remains here. So 2 into 7, that's 2. Why? Because I can only use 6. 6 divided by 3 is 2. 1 remains. I put the 1 here. 3 into 15 is 5. Can 3 go again? Let's check. 3 here, 15, 6, 18, that is 1 will remain. You put the 1 here. It can go here. That will be 12. But nothing will remain for us. No 1 is going to remain this time around to save us. So 3 cannot go. So we go to 5. Remember, 5 can divide any number that ends in 5. So 5. 5 into 1 can't. We add that 1 to 9. 5 into 19. We have 3. You couldn't make 4. Okay? You couldn't make 4. Had it been a hard 20, would have made 4. You only have 15. That's why we are having 3. All the 4, we are going to transfer the remaining 4 from 15, 16, 17, 18, 19 to this. So we have 42 here. 5 into 42, we know our 5 times table is 5 times 8, that gives 40. 5 times 9 is 45, bigger than this, so we stick to that. So that's 8. The remainder of 2, put the 2 here. 5 into 25 is 5. Can 5 still go? Of course, it ends in 5, so 5 will go. 5 into 3 can go into 38. That's 35. That is 7. The whole 3 is transferred here. The remaining 3, and this 77. What can go into 77? What else if not 7? Please note, I'm only picking prime numbers. I'm conscious to make sure I'm only picking prime numbers, not picking any other number. So 7 into 77 is 7 here 1, 7 here 1, that's 11. What can go into 11? The only prime number that can go into 11 is 11, and that is 1. So 1, 7, 3, 2, 5, 17,325 expressed as product of its prime is 3 times 3 times 5 times 5 times 7 times 11. So that is our final answer. But a question could actually ask you to leave your answer in index form. What does that mean? That means 3 raised to power 2, 5 raised to power 2. Why 2? 5 times 5 can be expressed in index form as 5 raised to power 2. 3 times 3 in index form can be expressed as 3 raised to power 2. Now 7 is just raised to power 1. We don't need to write 1. You are seeing only 1. We don't write it. Times 11. So this is the same answer but in index form, if the question asks you to write it in index form. Okay, thank you for watching. We've come to the end of the video, but please, before you go, kindly click the subscribe button, the follow button, the like button, as well as the notification bell to encourage us. Thank you. Until next time.